Alright, we're gonna do a two system change out on this job. We got some 10 seers. They got natural gas on the house, but they only put in, for the downstairs unit, they put in a gas furnace. For the upstairs unit, they put in a heat pump, which is kind of annoying because you save a lot of money with gas compared to heat pump. So I'm gonna go in with gas in the attic also and show the change out. And the other couple things, you see the units are kind of sliding down the hill. Here's what the attic looks like. They got a nice chaseway. Look, there's even a ladder in the chaseway. It's gonna be nice and easy to run the gas line up there. Here's the old unit. It's a heat pump. It's kind of annoying they put it kind of backwards. We gotta walk around the backside to reach the front. But we got plenty of room for gas furnace. Return air, I can move, it's flexible. Sheet metal ductwork. Looks like sheet metal return plenum. And it should work out pretty good. And then I'll do a roof penetration for the exhaust. I got plenty of room for that. So I got my cooling going to the attic. I got the house pressurized. I got 2 tons of window units. I got a downstairs, so I got 4 tons in the house. Pressurize the house, all the air is going up into the attic, and then it blows across onto me. And then here I'm fixing up the attic. I'm gonna deck it in. I'm double stacking the 2x4s. Double stack those, so we got 7 inches of insulation, and then I'm gonna put plywood down and start pulling out the furnace there. Gonna be a nice job when I finish. All right, I got the attic decked in. I did a nice job there, all the way in the back. I can put tools back there. It's up 7 inches high. Now it's time to start tearing out the old unit. Here you can see the freon leaks in the old coil. There's one right there dripping oil. It looks like 2, 3 little pinhole leaks, possibly 4 on the right. And that's what happens when they get old. And to show how the furnace goes into the attic, there's the hoist. Got the hoist tied off to the roof. Electric hoist. Got my strap around the unit. And then the unit just goes right through the hole. One man, take a unit right into the attic. Alright, I got my sheet metal in. Transition. I just custom made it right here. Tied into the old plenum. That'll get insulated. And then on the return, notice the furnace is quite a bit narrower than the return. And so rather than bottleneck the airflow through right there, I opened it up on the top. And so they can go right into the fan. And get plenty of return airflow, and that way the unit will run better. Yeah, on these carrier aluminum coils, they'll last forever, but you got to do a little trick here. Put a little silicone on the connection between the copper and the aluminum, and that'll prevent oxidation from the water, because these lines always run wet. Put a little silicone on there. Some other manufacturers do that already. If some reason carrier is not doing it, and then you'll never have a problem on that connection. I'm making the vent cap right now. Here's the vent cap for the downstairs heater. It's actually not the code. It's supposed to be 2 feet above the ridge, and that was the older code. New one, I got to do 2 feet above the ridge. It's nice having a battery saw or on the roof. I wanted to show a couple things about being on the roof. This roof's pretty steep, so I got special shoes. They have a great grip on the roof. And then the other thing, which is key, is how you do your ladder. That's really important, because this garage roof is even steeper. I got the ladder tied off, and then I got a board that's a stepping board. I'll show you when I'm down there, and where you can step on that. And there's a hole right here. I'm gonna patch that and get water inside the wood there. All right, a couple things about ladder safety here on a steep roof. Tie down the bottom of the ladder, which is right there, and then you tie down the top of the ladder, because you got to use the ladder to hang on. And if you don't have it tied down on the bottom, when you push on the top, it'll just kick the bottom right out. You'll be falling. So let me show you. Here's what I was talking about. A roofer showed me this trick. Just go ahead and screw in a board right there at the bottom. It makes it so nice. As you can see, it has a pretty steep pitch. It's about a 45 degree on this garage roof. I sure do like the view on these roofs here. It's a nice view. So here's the vent cap. It's 2 feet above the roof, the ridge line, and that's national code. Also, I use 50-year silicone. That silicone is aluminized. It'll never break down with sunlight. Shingles are nailed in. Also, I glue down the shingles after I lift them up. That stops the wind from feathering the shingles. And I got nails underneath the shingles like it's supposed to be. It looks good. Won't be any leaks here. Next, we're going to mount the unit supports. I have a heavy-duty hammer drill. And go right into that concrete there. These are kind of nice. They're powder coated, painted. They got screw holes to mount the unit, so the unit won't move or nobody can steal it. And mainly, I don't have to deal with this grade. I'll hold the camera level. We got a pretty steep grade here. Now I'm going to show how these wall mounts get mounted so they'll hold 600 pounds. And you have to have a special hammer drill, which is this one here, the Bulldog Extreme. And if you didn't have that drill, you ain't drilling through that. Set this right here. So first thing, of course, you mark your holes. Then mark your bit. That way you get them all the same depth. The drill cuts through this cement like butter. Then you use the hammer part to hammer the bolts in, because if you hammer them by hand, it'd be like 30 minutes per bolt trying to hammer it. Make sure your bolt's level. That's important. These are 1/2 inch masonry bolts. And it's important to get the dust out of the hole. You can see on the instructions here, drill, clean, drive. They're showing a hammer, which takes 30 minutes per bolt. I'll show you a fast way, and then tighten. Grab your bolts. Actually, here's my paintball CO2. Go all the way in the hole. Get that hole clean. You're not hammering that thing in if you don't clean that hole out. So you set the drill to hammer. I just changed to a shorter bit here. Putting the second system in the van. Fits nicely. See right there. As I use the bucket system, I can pull everything out, free up room, carry everything inside. Here I do my line set purge. I have compressed liquid CO2, and I can purge the old oil out of the suction line and the liquid line. Now I want to show a little video here soldering, and you want to get the oxygen out from inside the pipe so it doesn't build up slag. And you can use nitrogen, which is a pain with the big cylinder, or you can use CO2, which is also an inert gas. And the CO2, you know, it's a little paintball can. So you want to displace the oxygen inside the pipe with the CO2. And that way you can do a nice solder joint, nice and pretty. And you can leave it on there, but I'm just going to hit one joint at a time and then hit a little more CO2 through it. And then hit the other joint. And you always want to cover your pipe. Keep the moisture out, because the CO2 makes the pipe cold. And of course evacuate. It's just 1200 degree silver solder. I'll show some solder in here. So I'm purging the line with CO2 from the paintball cylinder. That displaces the oxygen inside the line. And there's no oxygen inside the line. It keeps the copper, keeps the slag off the copper, keeps it out of the compressor. Get another little purge here. Okay, now I'm going to leak check, and I'm going to put 100 psi of R410A. It's important to do 100 rather than 50 because it makes the leaks 4 times bigger. Whenever the pressure doubles, the leaks square on their size. This stuff here, this nylog, it fixes all the leaks that are mechanical. It's like a goop. Put it on these caps. That way when I evacuate, I'm not drawing in any air. It just basically is like a grease and never dries. It's got long polymers that basically clog up the mating surfaces. I got my evacuation going here. It's drawn down nicely. You can see 339 microns. I already did a hold test and holds under 1,000. That means the system's dry. But at that pressure, it's going to be extremely dry. I wanted to show about the aluminum wiring here. The correct way to install aluminum wiring. A lot of guys just put it in the terminal, crank it down, but you're actually supposed to put a special grease on there. The grease is made for aluminum wiring, antioxidant, and you grease it first, then you use the brush on it. That's how you get that. That's how you do all your aluminum wiring joints. 231 microns. Got a deep vacuum on it. Here's the downstairs system I'm changing out. I already had gas to it. There's an 80% train furnace, and I'm staying with 80% efficiency just because gas is so cheap. And it's going to be cheap for the next 20 years, or actually the next 50 years. And so, got the evaporator coil, and furnace. I'll be putting an air cleaner in, and also a humidifier. I'm going to put that on the return duct there. I wanted to show, here's what happens to these coils when these filters are used. These are the fiberglass ones. They're the 99-cent filters, but they don't really do very much. And because they look on the coil there, you can see how dirt's getting all caked up, and that coil was halfway blocked. And I'm going in with the air cleaner, which will never have that problem. But you know, when the coils get like this unit just doesn't cool. And these coils are hard to clean when it's really thick like that, because it sits on top of the furnace. And it's best to always use a pleated filter or an air cleaner instead of those fiberglass filters. So I'm hooking up the other system. I wanted to show I was sanding the old pipe here, and then it gets a bunch of sand grit inside the pipe. You can see that right in there. That stuff's bad for the compressor, and it can clog things up. So a cool way to clean this out, because I can't really shake it because the pipe is hooked up to the wall, a cool way to clean it is just pressurize it and then purge it out. See if I can show that right there. So I'm going to pressurize the other pipe, build up the pressure, and then I take the pressure off. And now if you notice, pipe is very clean on the inside there. I purged out all the grit that would shorten the life of the compressor or clog things up. So inside we got the furnace, air cleaner, some light on there. This is a big, I used the air cleaner for the 5-ton. Filter will last longer. It's a 20 by 25 by 5-inch filter. Notice I silicone everything. Everything's tight. I like to use silicone because it sticks, lasts forever. Got my transition there for the new coil to the existing ductwork. Got my humidifier. It's installed. I got it on the return air grill, or return air duct that is. And I just piped it in its supply. You'll notice it's siliconed. Everything's tight. Anytime I work on ductwork, I make it really tight. Got my gas line, it's hard piped in. It's got the trap on there. The trap will collect sediment. Power switch. And we'll be starting this up today. Here's the brain, which is a Honeywell IAQ thermostat. It'll control the humidifier solenoid and also dehumidify with the unit, run the heat, measure outside air temperature, and these work really nice. I want to show how you tested the humidifier's working. You check the drain, and you pinch it. See how the water backs up, and also you can hear the water running. I always put those silicone drains on there. It's easy to check it. And then also, if the humidifier ever has a problem, I have a wet switch here, which picks up moisture on the floor. It's like a little hockey puck. So, you know, if something happens, it overflows, the drain gets stopped up, starts picking up the water when it gets on the floor. It actually has a little pad that soaks up the water and goes to electrode, there, and then it'll turn red, shut down the unit. When the unit shuts down, the water will shut down. And checking my airflow on a downstairs unit, and we got 1088, which is good because we want 400 per ton. It's 2.5 tons, so we want 1000, and airflow looks good on the downstairs unit. And the upstairs unit's also 2.5 ton. It has 2 return airs. This one ended up being 830 CFM when I averaged the whole area. And then there's another one which was 300, so that's putting me at 1130, which is good. I got good airflow on the upstairs unit. I'm doing startup of the new gas heat furnace. So the first thing that happens is the inducer fan starts. It's running. Then next, the the hot surface ignition that starts glowing, and there's a computer in the furnace which checks the current to that. So once it gives time, then it turns on the main burner. Right there, the main burners are lit up. And then there's a flame sensor right there on the bottom. And it checks the resistance of the flame. Flames conduct electricity very well. So the burner started, and then after time delay, the main blower will start, which you can hear that started now. So upstairs furnace looks good, and here's the exhaust pipe that I put in right up to the roof there. We just had a hard rain. That looks good. Also, I got my 1-inch clearance to combustibles, actually more like 3 inches up there, all the way. Even right here, I went ahead and just sheeted the 2x4 to keep supposed to be a 3-inch clearance to combustibles on the front of the furnace. All right, here's the upstairs unit. Notice the attic is decked in nicely, easy to walk around. We got a return air, insulated. We got 2 ducts, those are existing. I also tied it off, and I raised this one up so it's easy to get to the other side. We got our new gas line, black iron. It's run. There's our gas shutoff valve. There's our electric shutoff for the furnace. Got the Bryant furnace. Since this is an attic, did 80%. That way don't have to worry about water freezing. Goes up out the roof right there. We got sheet metal transition. It's insulated. We got our Bryant coil, solid aluminum. Also, I slope it towards the drain. And then on the drain here, we got a few safeties because this is in an attic. We got a float switch similar to this one. I got it inside the pan. I got my secondary overflow turned up a little bit so that it can actually trip the float switch. We got our emergency pan, and on the emergency pan I'm just using it as a safety. It's got a safety switch here. The switch is glued to the pan, so if it overflows and the primary switch doesn't shut down the system, the secondary switch will. We got good slope on our drain line. It runs out. Ties into the existing drain line. On the back side right there, notice I'm using 45s instead of 90. That makes a difference, stopping the black algae from building up. We got our existing ductwork. I did a modification here to get good airflow. This unit has really good airflow, 1130 CFM, and then that just branches off. Existing ductwork. For the old circuit, I disconnected it at the box, and then it's also disconnected right there because we're not using heat pump anymore. Just straight gas heat, which is quite a bit cheaper than heat pump. And then attic's really nice being decked like this. I would have hated doing this job if I wouldn't have decked it, and because it's a balancing act if you don't have the decking down, so I can do a better quality job when I can work nice and easily. And notice I got the unit where you can stand up to work on it, and not the other way, you know, where you got to constantly, you know, be kneeling down, you know, breaking your back to work on a unit. So yeah, this gas conversion on the upstairs, it turned out real nice. Here's the downstairs unit. Humidifier. I have it with the bypass. I got the drain where it's easy to see that it's actually draining. You pinch it and you'll see the water raise. We got plenty of slope on the drains, See why I'm using 45s here? That keeps the drain nice and quiet. You don't get the dribbling noise. We got the new furnace for the downstairs, evaporator, double wall vent pipe we put in. We got an air cleaner right here with a massive HEPA filter in it. You just have to change this filter once a year. We got a wet switch, which I always put and when I have a humidifier, and it'll pick up any water that's on the floor and shut down the unit. And then the water for the humidifier, since this is I always tie it into the hot water and get more humidity out of it. Looks good. Gas line looks good. We got the 2 units running here. The mounts turned out nice. Nice and neat installation. Look inside here.